Yeah, well, you need to scroll the...
Like this.
Okay, if you want to use that.
Welcome. According to physicists in the community and outside appraisals, physics is in crisis. Books like these come out, and they state that math formalism and formulations represent progress. So they continue making more of these, adding complexity with every step. The hope is that at some point all of it will magically fall into place. This is kind of hope that consumes time and resources, creating additional problems rather than solving them. We have anomalies and paradoxes in all fundamental research areas. A blue ribbon panel documented 9 major long-term mysteries in 2004. 9. That's like trying to fight a battle with 9 fronts. This is something any commander would tell us is a battle we cannot win and in which we should not engage. Physics knowledge is a kind of information system. Here's a list of the major facilities producing more data and observations about those previous 9 mysteries, even though the information is known to possess critical defects. It's like doctors knowing they're losing the patient, but they don't know why. This Quantum Universe Committee report concluded that a revolution is needed. They called it a new Copernican revolution. And that was almost 10 years ago. Unlike physics, in business information systems, when we need to deliver that type of change, we use project management to ensure our efforts succeed. Why? Because if we don't, those projects always fail. Our project must deliver a revolutionary model meeting criteria for real-world verification. It means experiments which can show when we've made an error that we need to correct. We will address cost and schedule, but that's not our main concern. That verification against errors is the measure of progress, not increasingly complex math formulas. Responsibility for altering the course of physics research lies with each organization's leadership, and that leadership process starts with the vision of success. Clarifying and defining that vision is via a process called scoping. Scoping. Our vision of success in revolutionary physics is important to interstellar flight to the degree that it transforms our space capabilities. If we scope our goal in advance, we can more easily determine what needs to be done. What are the priorities and what work to avoid? This last point is important because as we're working, we are going to come up with good ideas that should be done. And that process can continue until the schedule and the budget have been completely consumed, but nothing's been completed. That process is called scope creep, and it is the largest known root cause of project failure. Unlike like the other big causes, these derive not from the genius scientists and engineers who are doing real work. It is the responsibility of leadership and management not being competently executed. The judgment of experts is supposed to be our primary planning resource, but a review of official guidelines from a number of sources, and I've been looking at a lot, if you read them, you would get the idea that experts in transformative, revolutionary change do not exist. They do. Some of these people look at the huge changes like the acceptance of round Earth orbiting the sun. Others of them look at minute changes like neuron capability in the brain during learning. We can leverage their latest to define our scope with precision that was impossible a couple of years ago. Good, precise research on revolutionary sciences in books like this, I think this is one of the best. The authors detail that perspective is the key. It is the key determinant in whether something is revolutionary science or mere innovation. Fire, our oldest invention, is magic if you've never seen it before. 400 years from now, or longer, When our starship breaks down in the middle of nowhere, we're not going to be oohing and eyeing over how awesome our technology is. It's all about perspective and what it is, your perspective, and what it is you're looking at. It's relational. For agencies which officially support revolutionary science to achieve that kind of goal, critical knowledge must be incorporated into their practices. This is not being done. Here, on the right, is a representation of how our brains relate concepts to each other, and it's a structure that they've identified as being maximally efficient for certain kinds of processing. In this case, concepts are being related in a structure that is a pre-Copernican paradigm for celestial motion, how the sun, planets, and stars move. Here we see a small change to that, where down at the bottom, over here, there's a delta V introduced. Changing velocity is impossible within a model of perfect, unchanging heavenly motion. A delta V acceleration caused by replacement of unchanging eternal heavens with dynamic orbits. In biology, this revolution consisted of replacing divinely created separate species with Darwin's dynamic process of natural selection. This is a key replacement of transformative model change. What this shows is that our perceptions are of a narrow spectrum, they're very short range, and they're pretty unreliable. So, a good heuristic to follow is humility. We need to be cautious and pay attention to our biases. They're perceptual based, and our perception is terrible. Reality is big and complex, and our brains tend to take things at face value. If the universe were revolving around us, the sky would look exactly the way it does. And that explanation should be good enough forever, unless we do something unnatural, like learn to keep records, do math, and take measurements. During the 1400s, kings, popes, the church, regular people were desperate because they couldn't figure out what day it was. People's spirits could be damned for praying to the wrong saint on the wrong day. Plus, complex societies like empires cannot be managed if you don't have a standardized calendar. Not only pressure from the calendar crisis motivated change. Whoever solved the date problem would be able to administratively run the table on the planet. By building a mathematical model simple enough to resolve those calendrical problems, Copernicus actually made everybody happy, and the Renaissance took off. There was a little side benefit. We got the very first scientific revolution and the creation of science. This shows the importance of taking into account our point of view, that future impacts from revolutions cover vast areas. They are much bigger than the immediate problems we are trying to solve. They go off in strange tangents. Those are unpredictable. So how does this historical research help us now? In two ways. First, we learn that we need to plan for those tangents in advance. The second is that to get from where we are today to those paradigms of the future, we need a concrete problem on which to work. Okay, the Nercession model out of Georgia Tech details processes by which new scientific knowledge is created, including revolutionary models. She agrees with the other authors in this field that concrete problems are key. What concrete problems might we choose for what we're here today? We go to the experts on space technology that we don't have today, but we expect to have at some point in the future. Science fiction is like the Sam's Club of visions for future technology, lots of which eventually get produced. What you see here is a very small sample. There are some huge lists, but the Kirk's communicator, that flip open thing, was actually used by the engineer to design his flip phone, the original Motorola micro TAC. Science fiction also produces the best elaborated visions of space scenarios and capabilities. Interstellar flight generally requires revolutionary physics. Sometimes they freeze people and send them off at relativistic speeds. Usually not the case. Future technologies like force fields and tractor beams, they might seem like good visionary goals to facilitate a revolution, but technically they are probably within the capability of current paradigms given some technological tweaking. Both teleportation and warp drive on this list would require redefinitions of fundamentals in current physics models. That redefinition would involve something like this domain used in science fiction. Warp and teleport also present the greatest opportunities for attendees here. Might such domains exist? A number of approaches are proposed for faster than light, pursuing it. Here's where we can, I took this list off of Wikipedia's entry on the subject. Here is where we get our first glimpse of the power of a disciplined approach. Since we should only invest our resources in issues that we're reasonably certain to be on the critical path of our project, and uncertainties in relativity affect the entire list of proposed solutions, then resolving uncertainty related to relativity is going to be on our critical path. Now, we have to identify a cause of problems and uncertainties before we can address it. And for that, we go to root cause analysis. In that analysis, when we work backward from problems reported by physicists and mathematicians, this is just the processes involved in root cause analysis. If we apply that to the problems in physics that gave rise to this crisis, we can hopefully identify the root of what we're experiencing now. We want to look closely at when initial reports started appearing of the things that we have now that have blossomed into this huge set of massive mysteries. We're looking for anything unusual that would seem to indicate, introduce significant risk, and anything that seems strange or unusual, and then also anything that relates to that advancement counts as progress if we can develop more complicated math equations. Checking the timeline, looking backward from, well, we're going to take the timeline from Galileo to just after Penrose wrote his comment that physicists are doubting reality at quantum scales, which excludes it from the realm of science. We look for the source of these risk triggers, and we zoom in on a section that is kind of attention-getting. We see an explosion of theorists right here, immediately following James Clerk Maxwell. Who was he? I have a very nice story, which I'm going to have to cut for time, regarding the famous Caltech professor of physics, David Goodstein, and I can cover that later in Q&A if we have time. Okay, advancing and summarizing the work of Michael Faraday, this guy. Maxwell discovered light was electromagnetic. He was the first person to do that. He investigated entropy, which defines the flow of time. He created a strong foundation from which some argue Einstein's relativity is trivial to construct mathematically. Maxwell's simultaneous successes from several angles suggested that Faraday's original hypothesis of a unifying structure underlying physics observation was at hand. It was not only plausible, but about to come about. And the math seemed more than adequate. But right at that point where we noticed this suspicious explosion, right at that point, and we're looking for anything unusual, something very unusual happened. An ugly, bitter dispute broke out in the science community. Maxwell's results had amazed the science community. Everybody wanted a piece of the action. Unfortunately, the quaternion math that Maxwell used was so hard, so new, and seemed so strange that almost no one had heard of it, much less understood it. It was widely considered unreliable, it was treated with suspicion, and Oliver Heaviside, this guy up here, argued for using 4 simpler equations. Those are now called the Maxwell equations. They're vector-based approximations of Maxwell's theory, which almost anyone could work with who was in the physics community. His opponent, Peter Tate, said, no, 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 you can't do that. It's not rigorous. You have to use Maxwell's critical 20 quaternion equations, and like all arguments, both sides had good points. The vector approximation ultimately won the day, and Maxwell diplomatically rationalized this, asking that people to learn all these things at the same time. Notation, new types of algebra, and a new physical theory would be unreasonable. Therefore, let them have at it with vectors. Now, to be fair, Heaviside was warned that his recommendation of vector approximations was dangerous. And his response was, quote, "What am I to do? Not eat my lunch when I'm hungry because I don't understand digestion?" Quaternion math gathered dust for the next 100 years, and it was revived because it is uniquely powerful. If you look it up in Wikipedia, it describes it as one of the most advanced forms of math available. Now, we've identified a model, and I'm going to have to go past all the quaternion stuff here. It's now used, interestingly, it's used in video games because quaternions can manipulate objects in 3 dimensions, rotate them, size them, scale them, and they don't have the problems that vectors do. That's why they got reanimated from the dead. And what else needs to model 3-dimensional phenomena without having infinities pop out all over the place? Physics theories need that, and we don't have it. Okay, we've identified a selected a vision of a starship that we want to pursue to orient our efforts. We've got a point of attack, but we still don't know how good that is. To verify the vision, we need to do a SWOT analysis. We can take a look at the strengths. They're pretty good, but I have to show this one thing about working on the warp drive. If we choose that, and that is this. This is a numerically categorized hierarchy of administrative and technical systems information for Starfleet's sovereign class starship. Okay? Now, this is not this is not up here to suggest that this is good for a plan or work breakdown structure or anything. But there are hundreds of people who worked on this stuff, and they've got thousands of missions and ships. This is untapped public goodwill that is incredible. I mean, it's priceless. I doubt you could buy this. As challenges in space continue to increase, the motivations and potential rewards will grow until they're irresistible. There are probably hundreds of specialized topics within each of this. I just left this conference in Pasadena. All of these things would be affected by Starship technology development, but we have to do the math first. And finally, aside from developing organizational maturity in leadership and management, we can start immediately to bring technical and math skills, like those quaternions, to bear, reworking the risky stuff that was introduced. By risky stuff, I mean the complex equations, like this week's headline in Physics Today, which was their top story, supergravity. Supergravity, as far as we know, doesn't relate to anything in the real world. Completely devoid from reality, but it's a new complex set of equations that somebody came up with, and no one's found fault with the derivations. That's the headline of progress in physics today. Now, the best, I made a career out of delivering impossible knowledge to my clients, relying on experts in the field, but most importantly, best practices of project management. And to my knowledge, they've never been used on the development of physics. I would bet that if using those practices and guidelines cannot make progress on resolving those in 18 months, I'd eat my hat. Here's a code for the website at which you can mail me. Thank you very much. I'm ready for questions.
We are running out of time, so we're having few questions. So,
Please, go ahead.
Mike, are you asking questions?
No,
Okay.
thank you.
Looking at your chart of the explosion after Maxwell, I'm going to draw a strange analogy. I just want to hear you say what you think of that. Do you see any analog between that and the explosion of interest, scholarship going on after the first 100-year Starship mission to today, all the people here working on stuff? And how do we keep that going given that the primary stakeholder has been chosen?
I somewhat do, but I think it's of less concern what's going on here because it's self-funded. Most people here are not diverting resources that would go into critical path activities, which is my focus is the success of the project, because that's what my clients pay for. Is they've got this problem that they can't solve, and I have to bring it in time for them to get their bonus.
So we'd all have to be paid to do this for it to.
Beg pardon?
We'd all have to be paid to do this for it to matter as much, basically, or.
Well, what you're in decision theory, you're not choosing between all or nothing. It's like the people who have done a lot of work here are going to continue doing that work, whether they're getting paid or not. But for example, if you want experiments run at CERN, it's different. There's real cash involved in those. Yes.
So the critical path for the 100-year Starship is to come up with a plan, right? The 2-year program they're funded for is to build a plan that will create the organization that's going to last 100 years. And that certainly falls under the ideas that you presented just now. Have you any way to contribute to that plan?
Do I have any way? Well, I can provide best practice project management. I can't do the research. I can make sure that the deliverables that are integrated are as successful as they can be made, given current knowledge. But there is something you said that there's an important distinction you need to make between facilitating processes and product processes. If our product is a functioning Starship, that's different. That's a type of work, but things that we need to do, like human resources, recruiting people, getting their taxes, getting their human resources stuff done, getting administrative help, that's a facilitating process, and planning is one of those facilitating processes. So planning you wouldn't put on the critical path for the product itself.
Okay, well,
but it has to be
for
done.
years, and to me a plan is defined in a statement of work that says exactly what steps have to be taken. And that's part of the critical. Defining that statement of work is part of the critical path. Yeah.
Overall, I agree. I like to maintain the distinction because sometimes it does get confused. But you're clear on that. Okay. Anyone else?
We will have to.
Okay.
Thank you very much.
Thank you.